Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast, coming to you from the studios of VK3 CSJ in Narre Warren South, broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater VK3RTV on digital channel 1, and also via my two streams on my YouTube channel VK3CSJ, just look for the live indicator, and also on my Discord HD stream, which if you haven't signed up to Discord, recommend signing up to Discord. On my qrz.com page, both my home call sign VK3CSJ and VK3EKH, I provide a link to the astronomy chat room, which also is associated with the HD stream. And I say that every time with Discord because it is a far better medium to watch, because it is less than a second delay from what you are hearing me on 80, and when it comes to the graphics I show, it's almost immediate, whereas with YouTube it's anything up to 20-second delay. Although with YouTube, of course, it's recording what's happening and what's going to the stream, whereas Discord doesn't record, and that's fine by me. Anyway, a very pleasant good evening to everybody that's happened to be listening. Congratulations to the Matildas, the soccer team that's just won 4-0. So that's New Zealand that was lost. Good match up there at Gosford, where it's not raining, I don't think, at the moment. It's raining here. It's raining mostly everywhere in Victoria at the moment. It's going to be a pretty lousy weekend. 14.6 degrees as I speak. All right. What else? I was hoping to, because we're coming up to a new month. So let me just back that audio down on YouTube. 1, 2, 3, 4, 5. Just to let that doesn't pick into the red so much. Because we're starting the 1st of December on Monday, I was hoping that there might have been some sky notes from the planetarium. It'll obviously come out over the weekend, but not queued up for my Friday night B-cast. So anyway, we'll go through the sky notes next Friday. But if you wish to look at the sky notes coming from the planetarium from Dr. Tanya Hill, the resident astronomer there, check out Science Works over the weekend. Just type in sky notes in the planetarium or the museum search engine, whatever, and you should be able to see it, hopefully. Anyways, let me see. All right, the first thing to get over and done with for the stations that might be just happen to be tuning in for the first time, the Astronomical Society of Victoria, the ASV. This broadcast is on behalf of that. VK3 EKH is the official call, been licensed since 1988, and the broadcast to 80 metres has been also occurring since about that time. The first 20 years was done by Russell Ward, VK3DRW. Pleasant evening to you there, Russell, if you're listening, and to Elizabeth that may be in the background there. And Russell did it for 20 years, and then went for a trip around Australia and decided that I'd be better doing it. To take over the microphone at least, and that's what I've been doing ever since. So whereas Russell only did the broadcast on 80 metres on 3541, Since I took over, I've included the video streams, whether it be through a TV repeater or the actual YouTube. So I figure when it comes to doing astronomy, there's a lot of pictures to show from time to time. So I figured running the broadcast through the Melbourne TV repeater when it was located up at Olinda was a real good thing to do. And then I ventured out onto YouTube and then eventually Discord. So I think the video side of the broadcast has been of some value and a benefit to those who regularly listen in on a Friday night, and I thank you for your patronage, as they say. And for the few that catch up with the YouTube stream later, they don't all watch it right now. But I note that the channel gets a bit active at odd times. So for those that like to listen in to what's been discussed, then yep, good, cool, thank you. Just ring the bell and subscribe, as they say. It's such a lot of nonsense, that. Anyway, all right. I've got a little black cat that's curled up between the computer and the monitor here at the moment. It's quite cute. She's feeling the warmth from the computer because I've got one cover off the computer, so she's feeling the warmth coming off from the motherboard. Little Tess. Anyway, enough of that. Let me have a quick blurb of the society like I normally do. I do have an artificial intelligence reading of this, but I don't know why I don't use it. The Astronomical Society, Victoria, founded 1922, comprises well over 1,600 members throughout Victoria, Australia and overseas. Membership of the Society is open to anyone with an interest in astronomy, of course. The Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science and provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month. Meetings start at 8 p.m. at the Mulia Hall, Burwood Avenue, near the Melbourne Observatory, and which is not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive and surrounding streets. Admission is free and visitors are most welcome. The meetings aim to finish at 10 o'clock and there's usually a free tea and coffee and some bickies that are available before disappearing. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV's magazine Crux containing articles, news, observing notes and the like. There's also the free provision of the Astronomical Yearbook, which is this guy. This is the yearbook that I'm reading from at the moment. Quite a substantial document that gets published by the ASV on an annual basis, called the yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. And there's also a 200mm refractor, which is managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and are accessible to members as well. The Society also has a number of 200mm reflectors available for short period loan via the ASV's telescope loan scheme. Did that last week too. So you can try before you buy concept. Regular Society Club Night meetings are held at the Melbourne Observatory in the Ellery Suite, Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of smaller reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use. The larger two, with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable 8.5-metre DS Kennedy dish antenna radio telescope, which members can get involved with via the radio astronomy section. Very pleasant good evening to any RAS members that are listening or watching tonight. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same thing. Instrument making, of course, is just one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics are all catered for. Historical studies and research in astronomy in general. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV website, and notifications of events are given in the Crux Extra bulletins, which are emails sent out via the ASV to the membership every other week, just to keep members up in abreast of what's happening and coming up. Please note that the ASV will conform to any government health directives, thus ASV events may be postponed, cancelled or moved, whatever. If you wish to send a letter to the ASV via normal post, please address the envelope to the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. Otherwise, visit the website at www.asv.org.au. That is www.asv.org.au, and all will be revealed about the Astronomical Society of Victoria, which is slowly getting bigger and bigger. The Bendigo Astronomical Society has now merged with the ASV. The Shepparton Astronomical Society has merged with the ASV. The Geelong Amateur Astronomical Society has merged. They're all individual sections that make up the ASV, in fact. And I think there's a Mildura Astronomical Society, which is also, I think, involved with things happening with the ASV. So one way or another, the membership of the ASV is growing, yeah, so I'll leave that all there, I think, at this point in time. Oh, I suppose I could make a plug for the ASV's Starbecue. Let me see if I can just bring that up on the screen. I just saw it a moment ago on the ASV's rolling banner. There it is. Let me cut to that quickly. Can I stop it? Can I stop it? Can I stop it? Yep, there it is. All right. So yes, so the what's happened? Oh, I've just lost the picture. No, there it is. So on a regular basis, the ASV opens up the site up at Heathcote to the public to come up and have a look at what it's like to look at the sky at night time, and it's pretty much open up from about 3 o'clock in the afternoon. I think they say midday, but you roll up there about 3 o'clock in the afternoon. Anyway, go to the ASV website. That page you're seeing on the screen right now is the link to more information about the Starbecue. There is a cost of obtaining a booking or a ticket, and it's all done online. and you just roll up there, I think with your printout, and Bob's your uncle. There is a food truck that comes in late in the afternoon to set up for dinner. So they provide things to eat around 6 o'clock to 7 o'clock for the evening meal, and drinks and ice cream. Because it's Christmas, there's usually somebody's dressed up as a Father Christmas for the kids, and to make it a fairly decent family event. Hopefully the weather will control itself, and won't be a problem. The thing about the dark sky site, the Leon Mao dark sky site, is that it's on the northern side of the Great Dividing Range, and if the weather is going to be pretty ordinary down here in Melbourne, you can be sure that by 7 o'clock or a little later, the sky will clear up, and it will look pretty good later. Usually that's the way it works, but there have been some barbecues where the weather just has been a real pain. But nevertheless, you get two, sometimes 300 people that roll up, and you can camp on the site. You can bring a tent up there, or I think caravans are allowed to some degree. That you might have to discuss that. But there is accommodation up there as well. Again, that's all involved with the booking process. So if you want to book a room, get that done pretty quickly. Otherwise, there is hotels and motels in Heathcote itself, if that's what you want to do. I've always come home. If I've ever gone up to Heathcote, invariably I stay there till about 2 o'clock in the morning, and think that's it, time to go home. So I do this drive, 2.5 hour drive home at 2-3 o'clock in the morning. It's something that I don't particularly wish to do anymore, to be honest. But it is good. I mean, I don't mind it. I get a bit sleepy, but I wind all the windows down and get a blast of cold air through the car. That helps. And I've usually got my music playing. And, at night time you seem to be always going faster anyway. So I always feel like I get home a lot quicker than I do during the day. It's just an illusion, of course. Anyway, that's the barbecue coming up on the 13th of December. So if you've never been up to the Leon Mao Dark Sky site, here's your chance. All right, now let me see. The first article that I've got tonight, there's a few things here actually. I might not get through them all, to be honest, but that's fine. I'd rather have more than less. And this first article, oops, that's the rain. Where are we? Looking for my, there it is. There, that's it. Why do brighter astronomical objects have a negative magnitudes? Why do brighter astronomical objects have negative magnitudes? And I've always wondered about that. This is published November 17, and courtesy of astronomy.com, and there is a picture associated with this article, so I might as well throw that up as well. And it says here that Sirius, the brightest star in the sky, blazes at apparent magnitude negative 1.44. Apparent magnitude negative or minus 1.44. Why is this? What is the baseline for determining the magnitude scale of celestial objects? Why do brighter objects have negative numbers? Have you ever asked that question? The first observer to catalogue differences in star brightness was Greek astronomer Hipparchus. He created a catalogue around 135 BCE of roughly 850 stars divided into 6 ranges. 850 stars divided into 6 ranges. He called the brightest first magnitude and the faintest 6th magnitude. Observers used this system for more than 1500 years. But then came Galileo Galilei. In addition to discovering the phases of Venus, Jupiter's large moons and more, he noted that his telescope did not simply magnify, it revealed the invisible. In 1610, Galileo coined a term that had not been used before when he called the brightest stars below naked eye visibility, or 7th magnitude. The telescope therefore demanded an expansion of Hipparchus' magnitude system, but not only on the faint end. Observers noted that first magnitude stars varied greatly in brightness. Also, to assign a magnitude to the brightest planets, the Moon and especially the Sun, scientists would have to work with negative numbers. In 1856, English astronomer Norman R. Pogson suggested astronomers calibrate all magnitudes so that a difference of 5 magnitudes would equal a brightness difference of 100. For example, a first magnitude star is 100 times brighter than a 6th magnitude one. We still use Pogson's formula today. Astronomers routinely use 2 main divisions of magnitudes to describe the same object. Apparent magnitude describes how bright an object looks. Back in the day, observers measured apparent magnitudes by eye. Now, ultra-sensitive CCD cameras provide measurements with accuracies of 0.01 of a magnitude. With absolute magnitude, astronomers indicate how bright an object magnitude and distance. Let me just read that sentence again. With absolute magnitude, astronomers indicate how bright an object really is, or its luminosity. 2 things determine this number: apparent magnitude and distance. Absolute magnitude defines an object's brightness if it were exactly 10 parsecs, or 32.6 light years from Earth. Absolute magnitude defines an object's brightness if it were exactly 10 parsecs, or 32.6 light years from Earth. So any object closer than 32.6 light years has an apparent magnitude brighter than its absolute magnitude. For any object farther away, the absolute magnitude is brightest. Good grief. I'm not sure that really helped to explain things, but there it is. So that's Sirius, which is considered the brightest star apart from the Sun. Sirius is the brightest star in the sky here in this part of the world, and blazes at an apparent magnitude of negative or minus 1.44. As no doubt, as I get more into the optical astronomy side of things, and get my telescopes finally up and running, I'll get more into an understanding of all that. It's certainly something that I've never really got into. You talk to me about radio astronomy, and that's different. I kind of know that subject, but optical astronomy is a new world to me. It's not just looking through a pair of binoculars anymore. In fact, I bought a telescope today off AliExpress. It's scheduled to arrive at before Christmas, the 18th of December. So I'll do a show. Actually, I won't be broadcasting then. I'm planning on finishing up on the 12th of December. Anyway, I'll eventually show you this telescope. It's only about so big, but it'll be used for looking at the sun, doing spectroscopy. Is that the right way of saying that? It's one of those tongue twisters. You're tuned to ASV Radio, VK3 Echo Kilo Hotel. What's next on this damn thing? Oh yes, okay, here's a little quick article. Not a happy article, but anyway, it's historic. It's historic. Courtesy of Astronomical, again, published November 21. On November 21, 1993, the death of Bruno Rossi. Bruno Rossi. You might wonder who Bruno Rossi was. Today, as in November 21, which was just the other day. When was it, in fact? Let me just check the date, calendar. The 21st was last Friday. Oh, okay, well, they published this article a little bit later, so there it is. Okay, today in the history of astronomy, astrophysicist pioneer passes away. Oh, and here is a picture of this bloke. There it is. You recognise him? Probably not. Bruno Rossi became known as the grandfather of high-energy astrophysics for his pioneer work. Born in Venice, Italy in 1905, Bruno Rossi attended the University of Bologna, graduating with a doctorate in physics in 1927. Okay, when race-based laws inspired by his country's growing closeness with Nazi Germany meant that Jewish Rossi had to leave Italy, he made his way to the US. In 1940, Rossi became an associated professor of physics at Cornell University, and from 1943 to 1946 he worked on the Manhattan Project at the Los Alamos Laboratory. After the war, Rossi joined the faculty of MIT, where he remained until he retired in the early 70s. Throughout his long career across countries and institutions, Rossi laid the groundwork for the study of several key fields in astronomy and astrophysics. His research into cosmic rays became the basis of high-energy particle physics, while his pioneering search for cosmic X-rays jump-started X-ray astronomy. Rossi also conducted trailblazing research into the interplanetary medium and contributed to the development of public policy for space exploration. Rossi passed away at the age of 88 on November 21, 1993. Today, as in November 21, today, among other honours and memorials that Rossi accrued, the Bruno B. Rossi Prize for Astrophysics is awarded yearly. Yes. To be a fortunate, intelligent, bright person and to get the opportunity to work in universities and develop amazing studies and theories and whatnot. It's a time gone by. But these days, of course, there is a surprising number of astronomers out there, people who have studied astrophysics at universities and getting into the field of astronomy in a big way, because these days, unlike in those days when Rossi was around, our modern day astronomers have some pretty amazing technology at their fingertips, whether it be powerful supercomputer systems, but as we all know, there are telescopes dotted around this world, both optical and radio telescopes, And of course we have some pretty magnificent machines operating out in space, all with the advent of further research in astronomy and discovering where we come from and what is it all about. Amazing stuff. If I was only a little bit smarter up here, I'd be an astrophysicist myself, and probably not here. Probably looking through some telescope on top of a mountain somewhere. But that's all right. I've got my own telescope 60 meters away from me here, and I'll be getting in there very, very soon. Well, I'll be using remote setup. I'm not going to be out there till 4 o'clock in the morning like I did a few weekends ago. It's true, that was freezing. It was freezing. I thought, why would you do this? Anyway, you're tuned to ASV Radio VK3EKH. Let me see what the next article is. I've got Tamitha on tonight too. She's got an article, an astronomy, a solar weather report is what I'm trying to say. Okay, this is a nice looking image. I think I've shown this particular image before. What's this all about, you might ask? Oh yeah. How long is this article? Okay, let's see, we can probably take 5 minutes on it. Courtesy of Astronomy.com. Could AI help us better understand the universe? Machine learning could help astronomers tighten constraints on the cosmological parameters that dictate the past, present and future of the cosmos. Courtesy of Astronomy.com. Actually this is published on June 30. It's a little bit old. In this image that you're seeing on the screen right now, the Hubble Space Telescope snapped this deep image of the galaxy cluster ACOS 295. Looking at the distribution of galaxies and clusters across the universe is helping astronomers better constrain the cosmos overarching properties. Anyway, for almost as long as humans have existed, we have been trying to make sense of the cosmos. What started as a philosophical musing has, following the event of the telescope and the ability to look even farther into space and even earlier into time, become a thriving field of research. Today, scientists seek to understand the properties governing how our universe behaves. These properties are characterized mathematically as so-called cosmological parameters, which fit into our models of the cosmos. The more precisely these parameters can be measured, the better we are able to differentiate between models as well as validate or rule out long-held theories, including Einstein's general theory of relativity, because different models can hold vastly different predictions for both our universe's earliest moments and eventual fate. That differentiation is vital. To date, some of the biggest challenges include more tightly constraining parameters such as those that determine the precise amount and nature of dark matter, the source of dark energy, and the repulsive force that it exerts, and exactly how neutrinos behave. These questions are the forefront of the field of cosmology. However, there is a catch. Probing these cosmic parameters is an expensive affair. There are so many experiments and astronomical surveys built just to measure these 6 or 10 major cosmological parameters, and they cost multiple billions of dollars, says Shirley Ho, professor of astrophysics at the Flatiron Institute in New York. In a paper published last August in Nature Astronomy, Ho and her colleagues leveraged artificial intelligence, AI, to calculate 5 of the major cosmological parameters governing dark matter, dark energy, and neutrinos to a higher degree of precision than ever before. They did so not only to show AI can make such calculations more precise, but also to show that this method is more cost effective as well. It's quite interesting what we've done in the paper, says Emily Hunt, an astronomer at the Max Planck Institute of Astronomy in Germany who was not involved with the research. Probing cosmological parameters typically requires studying how galaxies are distributed and their individual properties using surveys. Previous approaches used simplified models of the universe and compared them to the survey data. This approach mainly allows for a comparison of blurry, generalized models to the survey data, ignoring smaller details due to the expense and challenges associated with developing high-resolution models. Trying to look at the universe this way, however, is like wearing really bad glasses, says Ho. The new study used an AI framework called Simulation-Based Inference of Galaxies, or SIMBIG. Simulation-Based Inference of Galaxies, SIMBIG, SIMBIG, to extract cosmological information. The scientists first trained the AI model by presenting it with 2,000 simulated universes, each with different cosmological parameters. The researchers then introduced noise to make the artificial universes look more like what we're able to observe in our own due to inherent uncertainties in data gathered from galaxy surveys. The noise mimicked natural imperfections introduced by telescope instruments and the atmosphere, such as bright stars and objects that are so close together that their signals blend. Over time, the AI model was able to learn to extract hidden figures. While previous approaches were only able to look at large-scale distribution of galaxies, the new AI model learned how to leverage small-scale differences in galaxy distribution. For instance, the distance between individual galaxy pairs, to better estimate the desired cosmological parameters to a higher degree of accuracy. The trained AI model was then presented with more than 100,000 galaxies from the Sloan Digital Sky Survey, Baryon Oscillation Spectroscopic Survey, or BOSS. This is just a mere fraction of the total BOSS survey, less than 10%. The AI was then able to use both large and small scale information in the real data to more precisely constrain the cosmological parameters compared to previous methods. The advantage of machine learning is that you can just throw out these really powerful algorithms at data sort of blindly, and it might extract details that are not something that you would have thought of previously, says Hunt. The AI-driven approach is critical, since we don't have another universe, says Ho. Our best bet is actually to increase the precision as much as we can, to squeeze out as much information as we can from the existing universe that we have observed, she adds. Further surveys will be able to capture ever more information about the universe, and AI-powered insights, such as the ones offered by this study, may be useful in resolving some of the biggest cosmological conundrums today, including the so-called Hubble tension that surrounds the discrepancy in measured rate at which our present-day universe is expanding. This rate is given by the parameter HO, called the Hubble constant. If you have a much better constraint on HO, then you can really nail down whether there is a true Hubble tension or discrepancy, says Ho. So to catalyze further machine learning based research in astronomy, Ho and co-author Liam Parker have teamed up with other astronomers to create curate a large-scale collection of astronomical data. This effort combines hundreds of millions of publicly available datasets from major astronomical surveys in an effort to enable the development of large multi-models specifically targeted toward scientific applications. The authors write in an abstract available in the ARXIV preprint server. While the future of AI's application in astronomy seems promising, experts urge exercising caution when implementing these tools. With every breakthrough, certain things kind of race ahead. That's what they're saying. Certain things kind of race ahead, and then other stuff has to catch up. Understanding of the limitations and uncertainties of machine learning models is critical when applying their results to real-world applications, particularly when attempting to unlock the cosmos. Right. Could AI help us better understand the universe? Well, I think they've got a little bit more work there to go through from what I can see. You're tuned to ASV Radio, VK3 Echo Kilo Hotel with the regular Friday night broadcast. Okay, time is 19 minutes to. So, let me just see what I've got next in line. I'll make this a very quick one because it does go on a little bit and I'll run out of time for Tamitha. But I thought this was interesting. Let me just bring up the picture. Scientists crack open a lunar rock and found a huge surprise. ScienceAlert.com, published November 26. A tiny sample of the moon, locked away for more than 50 years, turns out to have been hiding an astronomical secret. In specks of troilite, dust collected by Apollo 17 in 1972, scientists have found material that may be as old or even older than the moon itself. A 4.5 billion year old relic of the early solar system. The author says here, my first thoughts was, holy shamoles, that can't be right, says planetary scientist James Dotton of the Brown University in the US. He says, so we went back to make sure we had done everything properly, and we had. And these are just very surprising results. During the 1960s and the early 1970s, NASA Apollo astronauts brought home to Earth a total of 382 kilograms of lunar material for scientists to study in labs that had a full suite of equipment not available on the moon. However, these scientists knew that one day more advanced technologies would vastly outperform their equipment, so they sealed up some of the rock samples to preserve them for that time. It's one of these preserved samples that Dotton and his team studied using mass spectrometry to determine the origin of sulfur in the sample. Sulfur is an important element for understanding the geological history of an object. It can bond with metals such as iron, move between a planet's core, mantle, and atmosphere, and preserve the isotopic fingerprints of the environment where it formed. Isotopes are versions of an element with different numbers of neutrons. Their ratios within a material differ depending on how that material was made. A chemical barcode of sorts, which scientists can use to trace samples' origin, for formation mechanism and age. The sample in Apollo 17's drive tube 730012 contained fragments of troilite, a compound of iron and sulfur most commonly found in space. Dalton and his team wanted to study the isotope ratios of sulfur in the troilite to learn more about the moon's history, specifically targeting grains that looked like they were volcanic in origin. And there's just a picture here of an astronaut on the moon, part of this article. What time is it? Okay. Some parts of the sample had slightly elevated levels of sulfur-33, an isotope pattern consistent with volcanic degassing, and Dalton and his team's expectations of lunar volcanic rock. But then other parts of the sample showed the opposite, isotope ratios shockingly depleted in sulfur-33. Before this, it was thought that the lunar mantle had the same sulfur isotope composition as Earth. And that's what Dalton says, that's what I expected to see when analysing these samples, but instead we saw values that were very different from anything we find on Earth. Alright, there's a few more paragraphs to that, but I'll just leave it there. That the picture on the screen at the moment is Apollo 17 lunar module pilot Harrison Schmitt using a sample collection scoop on the moon. And so this is what they found inside a sample. Rather amazing. Go back to that article. So what you're seeing there is a sulfur crystal, a sulfur crystal that was embedded inside a bit of moon rock. All right, I'm going to, at this point in time, I think that's about it. We'll pick up Tanya and see what she has to say about the latest in the solar report. Let me just queue up Tanya, and we'll go straight into that report. This goes for about 11 minutes, so it'll queue up nicely, I think. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Now crossing to Professor Dr. Tamitha Skov, Space Weather Woman, who is also a ham radio operator, and her call sign is WX6SWW. WX6SWW is her ham radio call. What an amazing young lady she is. Okay, here's Tamitha. Stand by.
We're in a bit of a hurry up and wait mode this week when it comes to space weather. As we take a look at our Earth-facing disk, we have been getting some fast solar wind from this irregularly shaped coronal hole. Some people say this hole looks a little bit like the back end of a bunny. I can kind of see that. Here's the cottontail, right? And you got maybe an ear here and an ear right there. These kinds of things are going to end up being more common over the next maybe 6 months or so as these coronal holes end up kind of being confined to this mid-latitude region. The reason for that is because you can actually see all these closed field regions in here. This is part of the heliospheric current sheet, and it's kind of confining these coronal holes to be in this mid-latitude region where we've got what I call the mid-latitude shredder, where all of these active regions kind of pop up, and they pop up in the middle of these structures. Plus, we're getting kind of this peeling off of the coronal hole off in these directions this way, both away, up toward the poles like that, along that symmetry axis. This kind of activity is completely normal for this part of the declining phase of the solar cycle. So expect to see more of this. This one might even survive its far side passage, and we'll see it again here in about a month. Meanwhile, as we take a look at the active regions, the ones on the front side of the disk are pretty quiet. We really haven't been getting any big flares, but the ones on the far side that are about to rotate back into Earth view, Well, those are another story, and we'll talk about them a little while later. Meanwhile, we've also got a really gorgeous filament structure right here. This thing has been bobbing and weaving in the high altitudes here in the solar corona for quite some time. It's really jailed hard by all of this closed field, though, here in this streamer belt region. So it's going to continue to be kind of leaking off a little bit, even with the big far-sided eruptions that we'll focus on here in just a sec so you can see it more clearly. It's really a beautiful structure. In fact, as we switch to our 304 angstrom sun, which gives you a better view of the material coming off, you can actually see I kind of dim those field lines down. You can really see how high it's sticking off of the solar surface. This is about 7 Earths off the solar surface. It's like a big skyscraper right now. And back on the 25th, when there was a big eruption, it actually bobbed and weaved. You'll see it right here in this close-up. Watch one of the big eruptions occur, boom, right there. Now look at this structure, boing, boing, boing. So it gives you a decent sense that this structure, even though it's unstable, it's really having to try to pop through a lot of closed field that is really kind of jailing it. So we will likely continue to see it leaking off instead of being one of those big, beautiful filament eruptions. And sadly, once it finally does erupt, it probably isn't going to be Earth direct. It may go too far north of us. However, we don't have to worry about solar storms because we are going to get some. As you notice, there was some stuff on the far side. You'll even see a big eruption here. Watch it here in just a second, late on the 25th. You'll see that, boom, that was a massive eruption. That is from good old region 4274, which is going to be rotating back into Earth view. You can see that it is actually busy, along with another one. You can actually see another one at the end of the 26th. You'll see yet another eruption. I don't think it's from the same region. It's one of the other regions that's coming. Let's see, it's right here. It's very dim. Boom, right there. You can see something on the far side that way. So we've got multiple eruptions that are big storm producers. They're likely big flare producers as well. They're both in the south and in the north, and we'll talk more about those in just a second as we get into that full sun map. But meanwhile, enjoy the fast wind from the Bunny coronal hole, and perhaps you might get a little bit of aurora from it. Now, switching to our full sun map, we do not have a solar orbiter or stereo data right this second to be able to fill out our full sun map, so we've only got 2 sources. We've got the SDO AIA imagery that's here in red. That's all the sun's front side. That's what we're looking at right now from Earth. And then we've got our JSOC helioseismology far-sighted viewer that's giving us a sounding of the sun from the far side. And just to give you a kind of an idea of where we are, you can see region 4286 and 4287. These regions haven't been all that active. That bunny coronal hole, you can kind of see it a little bit in this region here. That's the cottontail of the bunny. So it gives you an idea of where we are in the front side. But let's take a look at the far side for a second, because if you remember old friend 4274 that gave us that near G5 solar storm, really was almost a G5. If the G5 averaging had been a slightly different, the big indice averaging had been different, we would have actually seen a level G5 solar storm. But it didn't quite make it, just grazed the hairy edge of it. So it's still officially a G4, and region 4274 just kept firing off these big solar storms one after the other, and it looks like it is not done. So this region, along with 4272 and 4281, as well as some other regions in here that we'll look at in just a second, those are the regions that we're paying attention to. Those are the regions that have been firing off big solar storms on the far side and likely big flares as well. So they are going to be rotating here into Earth view over the next couple days. And the interesting thing about this is that when we take a look at our orbit disk here, you can see here's Earth, here's stereo A, and here is Mars on the sun's far side, right? So if there's somebody who might be looking, I don't know, like maybe Perseverance rover, taking a look at the sun's far side, it might actually be able to see sunspots if they're big. And in fact, as we do that, you'll see here, I'll step way off on this side, you'll end up seeing, look how close they are getting. Notice, before I pull it up, notice you've got 4274, you've got 4275 and 4281, as well as some regions in here that look like they're darkening. And this pattern here is super critical because when we pull up the Mars Perseverance rover, this was back on the 24th, it saw 3 soft spots right there. Do you see that? So this set here is region 4281. Take a look at how large this set of structures are. So it's pretty smeared out like that. We still have region 4274 as well as 4272, some cluster in there. And then we've got something in the middle. 4275, interesting, right? But watch the next day as well. Look, Now it looks like there might be one more. We've got a couple hot pixels because remember, this is masked Z. This is the left mast cam that is looking up from Perseverance Aurora right through the Mars atmosphere. So it's a little bit hard to see the high resolution, but it looks like this region is continuing to develop. If I back up again, actually, I think if I play it forward, it'll show it. It'll redo it. There you go. So see, you see a little bit of something there, but not too much. But the next day, it becomes a lot more visible. So definitely these are big enough regions to be seen as far away as Mars orbit. And so expect these regions as we move into the next few days, expect to start seeing that solar flare intensity pickup, the solar flux intensity pickup. We have risk for radio blackouts coming back again. You're going to see that risk for not just R1 and R2, but R3 level radio blackouts guaranteed as these regions rotate into view. And we might even have more than we bargained for because it's not just that one region that we're going to be dealing with. And now switching to our solar storm conditions and aurora possibilities over the coming week, we are dealing with that fast solar wind from that irregularly shaped coronal hole. And that brings us at high latitude. It's going to bring us some decent aurora. It already has been, and it's going to continue over the next couple days. So at high latitudes, NOAA is expecting major storm conditions with up to, in fact, about a 70% chance of major storm conditions. Probably won't reach a severe level, but this is going to kind of be off and on all the way through possibly Sunday. So your Thanksgiving weekend, if you happen to be in the States, you should get some decent aurora. So happy Thanksgiving. I hope you're grateful, as I will be, and enjoy it because things are going to calm down just a little bit as we move into Monday. But again, we've got those big regions rotating into Earth view. So high latitudes, I imagine you're going to get some bigger chances for bigger storming here pretty soon. Now, mid latitudes, well, we're only expecting active conditions, and it's likely only going to last through about Saturday before things really begin to calm down. Again, just looking at aurora watch. So if you're a dedicated chaser and you like chasing substorms, game is on. But if you're someone who's more casual, it may be better just to celebrate at home with family this weekend and enjoy looking at some of the aurora pictures you got from the big almost G5 storm that we had just a little while ago. And now as we switch to our solar flare and dayside radio blackout outlook over the coming week, we are sitting at about 120 to 125 right now for solar flux. Expect that to ramp up as we move in through the weekend, and that is because of big players that are rotating back into Earth view. We have minor noise on the bands right now, only expecting about a 15% chance of M-class flares at the R1 to R2 level radio blackout. But again, those are going to change. By Monday of next week, we could see a 40% chance of R1 to R2 level radio blackouts and about a 10% chance of R3 level radio blackouts. So expect that the conditions to change, expect the noise on the bands to rise, and expect to kind of hunker down as we move into next week. And now radiation storm and polar aviation outlook. Well, everything is in the green this week. We are sitting at the D1 normal range for you aviators at flight level 360. It's also the S0 quiet range for everyone else. But again, that could change very, very quickly as these regions rotate into Earth view. They did give us lots of radiation storms. So expect this forecast as we move into Monday of next week to change pretty dramatically. And if you're a frequent flyer, be sure to watch those ICAO advisories and pay attention because expect those big radio blackouts to cause you some issues, especially near dawn and near dusk. So the space weather this week is a bit of hurry up and wait. If you're an aurora photographer, you're in luck. We do have that Peter Cottontail coronal hole that's rotating through the Earth strike zone and sending us that fast solar wind. So at high latitudes, you're definitely getting shows, and that will continue over the next few days. If you're at mid latitudes, though, only if you're dedicated and you can chase substorms should you bother. Now, amateur radio operators and emergency responders, well, you know, right now things are quiet, but it's the calm before the storm because you've got the big regions that are going to be rotating back into Earth view. So expect that noise floor on the dayside radio bands to start rising in and around the weekend, and expect the risk for radio blackouts to go way up into next week. You're probably going to have to hunker down. So get those contacts while you can. And now you GPS users, well, you know, we've got a little bit of storming on the night side, but the day side is pretty good for at least the next couple days. So as long as you stay away from dawn and dusk and you stay vigilant anywhere near aurora, your GPS should be pretty good.
1, 2, 3. Oh, there I am. Okay. Right. Yep. I think we got that sorted out. All very good. All very good. Thanks, Tamitha. We got to hunker down. Hunker. Was it hunker? Hunker down. Hunker down this Thanksgiving. Happy Thanksgiving to those that celebrate Happy Thanksgiving. Not in this country. But anyway, good grief. Dear. To be an American. All right. So there it is. It's now 11 o'clock in the evening. And what I will do is just quickly cover spaceweather.com, just because I can. Carry on for a little bit further from what Tamitha was just saying. If we could look at the sun right now, this is what we would see. All those wonderful sunspots. And the solar wind is currently at 637.4 kilometres a second. It is blowing a hurricane at a density of 1.33 protons per cubic centimetre. And the sunspot number is 76. And the current auroral glow over Antarctica looks a bit like this. As I look at my geochron monitor, it's about the same. This was taken about an hour ago. So there's a little bit of aurora activity. If you lived off the southern part of Tasmania there, you'd probably notice a bit of a greenish glow in the sky, or maybe a magenta sort of a glow perhaps. Okay. And the coronal hole, or corona as it is looking like that at the moment. So there's no major coronal hole that you can see there. And the planetary K index is 4. Planetary K index, KP, is equal to 4 unsettled. Over the next 24 hours, it'll go to 4.67 and considered as unsettled. Oh, there is a coronal hole there. It's up there in the left-hand side of the image there. Okay, the radio sun, measured at a wavelength of 10.7 centimetres, is 120 solar flux units. 120 solar flux units. And I can show you, like I have been doing lately, the current chart for the solar cycle. The top one is the sunspot cycle, the bottom one is the radio version of that. As you can see, they're pretty much mirroring each other. And another thing they've got here is they say that Earth is exiting the solar wind stream, as Tamitha was saying. After 3 days blowing faster than 700 kilometres a second, the solar wind is now slowing down. Intermittent G1 class geomagnetic storms registered on November 25 to 27. And will now subside, apparently. Setting stage for a quiet weekend. No auroras are in the forecast, according to spaceweather.com. And finally, there's this interesting little image from spaceweather.com. Go ahead on that and put a loop on it. This is a bonfire of hydrogen, as Jerry Lewis would do in The Nutty Professor. Hydrogen. A bonfire of hydrogen. There is no combustion on the sun. Even so, on November 25, amateur astronomer Dave Wilson of Inverness, Scotland, saw a tremendous bonfire. He says, I only had time to record 22 minutes of this prominence, but it still looked pretty awesome to me, he said. Although this looks like fire, it is not. The towering flame is actually made of hydrogen and magnesium, heated by fusion deep inside the body of the sun. There's not enough water on Earth to put it out. Indeed, it is 5 times taller than our entire planet. And there's a correction here. It was 5 times taller. It's gone now. The twisting motion Wilson captured in this movie, or in his movie, was caused by magnetic fields within the bonfire to wind up and explode. And then there's a coronagraph image I've got here too. I think of the same thing perhaps. Yes. Coronagraphs on board the Solar and Heliospheric Observatory, SOHO, captured the jet-like eruptions on November 27. The dense plume would cause a strong geomagnetic storm if in fact it hit Earth, but it didn't. However, it sailed harmlessly above the ecliptic plane. No storms will result. So, yeah. All right. And as of the 28th of November, there were 2,349 potentially hazardous asteroids. But none of those asteroids are on a collision course with Earth, so we have nothing to worry about. Okay, on that note, I shall conclude the transmission for tonight at almost 7 minutes past the hour. So I shall now open up 3541 kilohertz for any stations wishing to check in. I'll just have a quick look at Discord, and I see that David, the resident astronomer there for the Mount Burnett Observatory, is there. G'day, David. G'day, Steve, Mr. VK3SPX. G'day, Mitch, VK3ZT. And Andrew, VK3KIS, are all watching the visions here on Discord. No emails have come through, although I didn't really make a big deal about the email address earlier on this evening. So I don't see any emails that have come through, but that's okay. Not a problem. All right, this is VK3EKH, listening on 3541 kilohertz for any stations wishing to check in.
VK3 Tango Juliet, yeah. VK3SPX.
Okay, acknowledging VK3TJS and VK3SPX. Any other stations?
VK5 Charlie Victor, VK5 CV.
I'm not sure there's another station there, but VK5 Charlie Victor. Good evening to you. Thanks for joining in. All right, over to you there, Jack, up there in Shepparton. And I'm sure that the amount of lightning activity that's going on is probably making things a bit difficult too. It's quite the atmosphere is quite noisy at the moment. VK3TJS, VK3EKH.
VK3KH, this is VK3TJS, and thank you very much, Keith, for running the broadcast and good transmission. No problem here. You're quite right. That's why we have crossings going on, but they're not overly, disturbing me yet. It's still rain, just 2 drops falling, but there's a lot more forecast for later in the night, I think, so might be having quite a bit of rain there, so I think we're looking forward to this. I find that it's been rather dry, so good rain is good access to water. So thanks again for the broadcast. Steve from CX and some other stations as well. And we'll catch up with you next time. Have a good weekend. VK3 EKH in the group, VK3TJS, and hopefully you're getting me okay.
Yeah, no worries, Jack. VK3TJS, VK3EKH. Signal actually started to pick up there towards the end, as it always seems to do. But I copied you pretty well. Not a problem at all. You were coming up to 25 to 30 over 9, just as you were putting it across to me. But no worries, Jack. And note the rain. Most of Victoria is definitely still needs a bit more water, I think. So I think with the next few days, hopefully there will be more rain needed in those drier areas of Victoria, because there are still quite some dry areas, that is for sure, despite where the rain is falling. It's not falling as much in the right areas where it needs to. But summer's not too far away, so those hotter days are going to come racing through, and all that greenness that we're seeing out in the country will change colour fairly quickly. Anyway, that's another story. Thanks, Jack. Good on you, mate. You too. Have a nice weekend. Steve, VK3SBX, VK3EKH.
VK3EKH, this is VK3SBS. G'day Clint and Jack and VK5CV, I'm not sure of your name. Yeah, it is a bit wet at the moment, isn't it? A whole bunch of people from the Bendigo Club are actually camping out tonight at the place where we've got this radio tower in Gredgewin in northern Victoria. So, yeah, I'm not sorry I'm not there at the moment. I am going up tomorrow, but I'm gonna camp in the local holiday park. No canvas for me. Anyway, yeah, thanks for the broadcast there, Clint. I note your new solar telescope you mentioned there, so that'll be interesting to have a look at that. You just showed that so-called bonfire of hydrogen. That was amazing, wasn't it?
Oh, yeah.
So I guess that's what the sort of thing you'll be trying to capture. That was awesome photos there. So, yeah, anyway, just to know what you've gone and bought there, Clint. I know you get the solar telescopes with the HA filters with incredibly small bandwidth. I'm wondering if that's what you've got, or whether it's something with neutral density in front. So interesting to find out about that. But you'll be able to do some astronomy in the middle of the day if you have to stay up late at night. That's certainly one advantage of solar astronomy, isn't it? Anyway, thanks very much, Clint. We'll see you again soon. VK3EKH, VK3SPX.
Press the wrong button. No worries, Steve. Good on you. VK3SBX, VK3EKH. I'll send you a link for this particular telescope. It's as you know, I've got the spectrometer scope thingy from the SHG 700. SGH 700. I showed it on here a few weeks ago. It needs a telescope with no more than a focal length of. If you wanted to get the sun, the full disk of the sun, it's ideally a 700 a focal length telescope with a focal length of 700 millimeter. And I don't have that. The three telescopes that I've got have much longer focal length, so I can't really put the spectrometer on the Celestron. Wouldn't really work very well. It's not really, these instruments aren't really designed to be stuck on a reflector telescope sitting out at the side of the tube. There's too much weight on the side of the tube, so a refractor is the preferred telescope to use for this particular instrument. And so I knew I wasn't too sure on the onset whether one of the telescopes I've got would have worked, particularly the 6-inch refractor that I've got. I thought it might have been okay on that, but the 6-inch refractor has a focal length of 1,000 millimeters, and so it means that I wouldn't be able to get a full, just a disk view of the sun. And the way this spectrometer works, it needs to be able to scan the whole disk of the sun, the whole face, for it to do its thing. So today, now I must admit, I know it's this black, what do they call it? Black, dark, what is it? Black Friday or something. I didn't take advantage of that, but it turns out that it worked in my favour because it made things a bit cheaper. So I emailed the guy who makes these spectrometer things, heliospectrographs, and I asked him what would be an ideal, or at least a telescope with an FL of 700 millimeters, and he actually replied pretty quick, within 5-10 minutes. And the first question was about a camera, because this unit, this test instrument, needs a camera, and I needed to work out. I asked a question about the camera, so I've got the camera coming from Sydney, and then I asked the question about the telescope itself, and he suggested that there's a telescope that you can get off AliExpress from China. That's relatively cheap, that will actually do the job for this. So anyway, I'll send you the link so you can peruse it. It apparently will do the job, and I believe it will. And I'm just going through some YouTube reviews of this particular telescope. So far it's a bit of a thumbs up for the people that are reviewing this particular telescope. It looks like it's actually not too bad. So it'll form part of my solar observatory. Fortunately, the telescope, it's a 4-inch aperture, and it'll make setting up the telescope for looking at the sun fairly easy. Actually, I have a question about this, and I'm not sure. This is one of these silly question. A silly question. Even though this telescope's going to be looking at the sun with the spectrometer device attached to it, I wonder, I'm not certain whether you still need to apply a filter to the front of the telescope, or whether it's because we're not looking through it by eye. This is not a visual observation where I'm looking down the eyepiece at the sun. That's a different thing, and I can understand putting the appropriate filter in front of the telescope. But in this case, we're fitting the spectrometer device to the eyepiece section and putting a camera on it. But I'm still not 100% sure whether the telescope needs to be protected by a filter on the front of it, or whether it's okay not to have it there. I'm not 100% sure on that. It's a silly question type thing. So if you've got an answer to that, you can let me know. It's a big learning curve, this stuff. All right, look, I'll pop it across to VK5CV, and we'll find out all about VK5CV. VK5 Charlie Victor. This is VK3 Echo Kilo Hotel. The name is Clint. Charlie Lima India November Tango. Clint is the name. Go ahead. Yeah, thanks, Andrew. VK5 Charlie Victor, VK3 EKH, VK3 CSJ on the microphone. No worries, Andrew. Thanks for calling in. Good to hear for the first time. We've put you in the log there, and great to meet your acquaintance as such. Note that astronomy in general is not necessarily a big thing for you. It's okay, it's fine, it's no problem at all. I always try to make the Friday night session of some interest with the articles that I show, and of course the report from Tamitha. And if there is any other audio recordings or videos that I can play, then I do, just to make it the time flow a little bit. So I'm glad you have found it of some value and some interest. So we're about to finish up at the end of the year. I think that I'll probably make the 12th of December my last broadcast for this year. I've got some time off over Christmas. I usually take off a few weeks over Christmas, and then come back in late January. So there will be a bit of a break over the Christmas period, and hopefully I can get my Radio Shack sorted out, because it's just a mess at the moment. Not sure if you're watching on YouTube or the Discord. My stream is still working. It hasn't fallen over, thank goodness. But VK3CSJ on YouTube, you'll find the stream there. Thanks, Andrew. Good on you, mate. Thanks for calling in. Really appreciate hearing you. You're 590. You're not super strong. You're about 10-15 over 9, around about the 15 over 9 mark. The lightning crashes are competing a little bit with you, but otherwise fairly readable, so not a problem there. All right. Is there any other stations that might want to quickly call in? VK3EKH listening? All right. Steve, do you have any other comments? VK3SPX, VK3EKH?
VK3EKH, VK3SPX. Clint, I would be astonished if you didn't need a filter. I'm not sure what sort of camera you're using, but they're quite sensitive, and they just, if it wasn't for just ignoring the heat and other issues at the moment, you need an exposure about a microsecond to actually to expose it to the normal degree. Of course, you don't want exposure of microsecond if you actually want some sort of analysis or something. I guess if you're using a spectrometer, you're going to need a neutral density type filter, and I'm sure there are plenty of those available. I know people often use the hydrogen alpha filters. In fact, I think you get 2 of them, and you kind of rotate one. I forget how it works, but some of the dedicated solar telescopes. I know the Ray from the ASC has one. I've seen demonstrate a couple of times, and with the very, very, very narrow band hydrogen alpha filters, like 0.1 of a nanometer or something, cuts out the light by just cutting out 99.999% of all wavelengths. But that wouldn't work if you're going to analyse the spectrum, would it? So you want a neutral density filter. So I think you need to do a little bit of research there. I'm certainly not an expert in that, Clint, but I would be absolutely not. Just the heat coming onto a camera, ignoring how bright it is. I think I think the camera would be instantly zapped, basically. But anyway, I mean, obviously not going to look through it, but still the camera and your spectra scope, are going to have a certain range at which they can work. So that's all I think, Clint, although I'm not an expert in the field. I'm usually looking at things about 16 magnitudes less. You were talking about magnitude earlier. I think what the sun is, it's about minus 20 or something, isn't it?
Something like that.
Now exactly. I think they can work down to about a magnitude of about 16. So you can just imagine how different that is. All right. No worries. EK3, EKH, EK3, SPS.
Good on you, Steve. Thanks. Yeah, look, I that's exactly what I was afraid of. The last thing I want to do is to stuff things up I know, like most of astronomers, or if not all, realise that pointing telescopes at the sun is something you've got to be extremely careful at doing. Not so much just if you're going to be looking at the telescope. Obviously, you got to have protection on the front of the telescope for that. I think everybody knows that. I did actually ask the question of his name's Ming, the guy who makes this spectrograph. His name's Ming Trong, or Ming something or other. And Mel Astro, I think, is the website. But I actually asked him the question in the last paragraph. I mean, it was just a very quick response email. But like I just said, it was a silly question type thing, and I said, just excuse me, this is a sort of a silly question, but will the telescope need to have some sort of solar protection on the front of it? He actually didn't really respond to that. He didn't reply to that. So he did the other question. But anyway, I shall do some research, as you say, and I shall make sure that I do the right thing before I do anything. Yeah. See, the spectrograph has a slit in its setup, and there's a calibration on the side of it that allows you to look at the different. You can adjust it so that it looks at the different wavelengths. And I'm not 100% sure how it works, but once you fit the appropriate camera to this, it's a Tuvok camera. Tuvok. That's the fellow from Star Trek. But it's what's the brand name now? Oh, look, I'll send you an email on all this, what I've spent money on today, so you can get a bit of an idea. And I'll ask the question about putting something on the front of the telescope, because I'm fairly certain it will need to have something fitted to the front. Otherwise, it'll cook things, I'm sure. Anyway, we'll find out, and make sure that we do the right thing. But I'm looking forward to being able to look at the sun in different wavelengths, and it'll cater for a few of them. So anyway, we'll see how we go. Okay, thanks, Steve. Not a problem at all. All right, this is VK3 EKH concluding tonight. Thank you everybody for listening, and we'll be back next week, which will be December. It will be the 5th of December, and then the following week will be the 12th, and I've got 2 more weeks, and then I'll go off for a bit of a break. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, concluding transmissions for this date of the 28th of November. Thank you for listening and watching, and we'll be back on Sunday morning to do the WI broadcast on 1825 kilohertz AM with the Telefunken, and then through the repeater, ATV repeater at 10:30, and then again at 8 o'clock Sunday night. Yes, I'm after signal reports for the broadcast on Sunday morning. So if anybody can tune in to 1825 kilohertz at 9 o'clock on Sunday morning and give us a report on the AM signal, I'd appreciate it. That's all I'm after, is just a signal report. Cheers everyone, take care. VK3 EKH with VK3 CSJ on the microphone concluding. And we say a very pleasant evening to people watching on TV. I'm glad to see that my YouTube stream hung in there. Look at that, it's still hanging in. There's been no dropouts. I'm running more power. Go figure. I am running more power here, and the modem is still hanging in. Maybe I've gone beyond a threshold or something like that. I don't know. Anyway, I'm just glad that it hasn't fallen over. Anyway, I'm going to get out of this chair because I can feel the cold temperature coming in through the window not too far from me. It's 13.6 degrees here in Narre South, so I can't tell you how much rain's fallen because my rain gauge isn't working. I've got to fix that. Anyway, on that note, we shall conclude from the video streams and from the TV repeater, and let's have a quick look at the all-sky camera up at Heathcote. And what do we see but cloud and water drops on the camera? So there's not a whole lot that's visual up at Heathcote as we speak. That's just the nature of the beast. So on that note, cheers everyone, take care, stand by for colour bars and test pattern, and then we'll be going to some live, well actually it's not really live footage of flying over the Earth, but I'll keep that running for a little while on the Discord stream. Cheers everyone, take care, and happy Thanksgiving. Just enjoy your roast chook tomorrow night, that's all you got to do, nothing else. Anyway, where's my fader? Oh, here it is. All right. Cheers, everyone. Take care.